Hey guys, welcome to my first video, and today we'll be talking about sequences. Now, sequences can be referred to an ongoing pattern of a sequence. So basically, there are different segments in mathematics and they have names for it and different rules. So as you can see on the screen, there are cubic sequences, arithmetic sequences, geometric sequences, and quadratic sequences, and there must be more. But today, we'll mainly focus on arithmetic sequences. Now, you may be confused or you may be not familiar what arithmetic sequences are. However, arithmetic sequences is a sequence of numbers that the difference between each consecutive term is constant. So for instance, let's look at a clear example. So we have 1, 2, 3, 4, and 5. Now let's look at the gaps in between. So to get to 1 to 2, it's plus 1. To get to 2 to 3, it's plus 1 again. 3 to 4 plus 1 as well, and 4 to 5 plus 1. Now this is a constant common difference. So this is a main segment that arithmetic sequences need to have in order to be called arithmetic. Now let's get into more of the application wise and formula making wise. So let's see something. So the nth term is something that is very significant in this topic, and that applies to a large proportion to all of these sequences. So nth term is basically a formula to get either the values of the values of the respective terms of each sequence, and it could be and it is a generated formula made by a certain sequence. So let's get into more of the formula side. So we have the nth term is equal to this is the first term plus n minus 1. The n is basically the term number, and multiplied by the common difference, which is d. That's different. So a1 is considered the first term of the sequence. N minus 1 is taken as an expression, so we wouldn't change this. And d would be the common difference or the constant difference or gap for a sequence. Now make sure you have this properly written. Now we'll be using this formula later on. So now let's look at a different example. So a different arithmetic sequence pattern. Let's see 4, 9, 14, and we'll have 19 here. All right, now let's look at the differences. Now we have 4 to 9 is 5, 9 to 14 is 5 as well, 14 to 19, 5. Is the plus there? All right, now it indicates that there's a common difference of 5. So now let's apply this formula here to get the nth term. So the first term here is 4. So let's plug in the values. Let's make a separation here. So 4, now plus, as I said, n minus 1 is an expression, and n is a term number. So n minus 1 stays there. And d is a common difference or the constant gap. So we have 5 here. Now, this requires a bit of algebra, and that's expanding brackets. 4 plus, now it's 5 into n minus 1. So in algebra, what we do here is we multiply the outside number with each term inside the brackets respectively. So 5 into n and 5 into negative 1. And take the sign before. So it becomes 5 into n, so that's 5n, and 5 into negative 1, and that becomes 5n minus 5. So this becomes 5n minus 5. The brackets here is not required. So we've expanded it. All right, we have 5n minus 5s. So let's keep 5n aside because it's one term that is not there in other terms of this expression. And now we have 4 and negative 5. So 4 minus 5 is negative 1. And now we have our official nth term. Now let's test it out, because we can't approve it without testing. So let's test it. So as I said, n is the pattern number. So this is the pattern number. So let's test it. So let's use the second term, and we're supposed to get 9. So that's 5n. So n is going to be our second term, and minus 1 as per the formula. So that's 10 minus 1. So 10 minus 1 is also equal to 9. And that is what we're getting all the way here. Now let's test one more for a double proof. So let's take our third term and apply it to our formula. And we're supposed to get 5 into 3, 15, minus 1 is 14. And that works as well. So now we can prove that this formula works. Now let's look at another example. Let's look at 5, 8, 11, and 14. Now let's look at the common difference. So plus 3, 2 plus 3, and 2 plus 3. So now we have our d value, that's the constant gap. We have the first term, and we have the expression for the formula. So we know the nth term is first term plus the expression n minus 1 multiplied by the difference. So the first term here is 5 plus, so we have n minus 1 as an expression, multiplied by 3. That is a common or constant gap. So let's now expand the brackets. So it's 3 and minus 1, and this becomes 3 and minus 3. 5 plus 3 and minus 3. Alright, so now 3 aside because it's not within the like terms of this expression. And now we have 5 minus 3. So 5 minus 3 is simply equal to 2. So that's positive 2. Let's see if this nth term is valid. So let's take the third term. And the third term is 11. Let's see what we get. So simply replace n as 3 for this formula. So just 3 multiplied by 3 plus 2. That's 9 plus 2, which is 11. And that is right. That is our third term. Now let's put n as 1. Let's see what our first term is. So 3 into 1 plus 2 is getting us a value of 5. And that is right. Our value is 5. So now we can prove that this formula, this entire formula, is correct. So as we're getting 3n plus 2, we can prove that the formula links accordingly to our sequence.